Hello dear students, welcome to the second video on the topic of thermodynamics. We shall continue our explanation of various terms and new physical quantities we are introducing in this particular topic. I shall try and keep these videos simple and short so that you are able to relate to this topic, because from my experience students find this topic very confusing and difficult to understand. The thermodynamic quantity we are introducing now is internal energy. First of all, you need to understand here that this internal energy we are talking about, it's an intrinsic property. It's a property related to a system. What is it dependent on? It is dependent on the kinetic and potential energy of the particles of a system. We are not talking about the external. So if supposing I have a pen and I raise it higher or I bring it down lower, no. We are not talking about the changes in kinetic and potential energy of this pen on a macroscopic scale. No. Here we are talking about the kinetic energy of the particles as part of the system. We know that particles of a system are in a state of continuous random motion. So they have translational energy. They have vibrational energy because they are also vibrating on their own axis. They have rotational kinetic energy because they are moving with respect to each other as well in a system. Potential energy, the form of energy which gets generated due to interaction between two particles. So that could be bond energy, electronic energy, and all the other different forms of energy that we can think of. That means this is an energy associated on a microscopic level with the particles of a system. We define it as the total energy stored in a system as its kinetic and potential energy related to its particles. Again, because it's an energy which is associated with the particles, unlike a pen where I can calculate the change in kinetic and potential energy by the formulas half mv square and mgh like you do in physics, it is not possible to determine the internal energy of any system, of any body. So if I talk about the internal energy of this pen, I cannot determine the internal energy of this pen. But what we can determine is the change. So supposing I burn this pen, so what will be the change in internal energy can be determined by various experiments. But the internal energy depends on the temperature. When we are talking about an ideal system, in an ideal system, in an ideal gas, we know that there is no change in the potential energy because ideal system means the particles do not interact with each other. In such a case, the internal energy is a function of only the temperature. The symbol for internal energy is U, although in some books and some places you will also find the symbol E. Please do not get confused, do not worry about it. Most of the places use U. The IUPAC system says U, but many of the books still continue to use E. Delta U. Delta is a symbol we shall use to denote change in any of the headings under the topic of thermodynamics. In general, delta represents change. So delta U, when you are carrying out a process, changing it from one state to the other, delta U is the energy of the final state minus the energy of the initial state. Now, why are we talking about final or initial when we can't measure it also? Because this will tell us whether energy is released or absorbed. So if the energy of the final state is more than the energy of the initial state, so let us suppose delta U is U2 minus U1. If your U2 is greater than U1, in that case delta U will be positive. On the other hand, if the energy of the initial state is greater than the final state, In that case, delta U becomes a negative value, and this explains whether energy will be released or it will be absorbed. P is for the products, R is for the reactants. This is the change in internal energy when we are talking about a chemical process happening. For example, I spoke about burning a pen. So UP minus UR, internal energy of the products minus internal energy of the reactants. It is an extensive property because we know that it is depending on the particles. So more the number of particles in a system, the internal energy will be different from its initial state. The unit of energy, since it's simply a form of energy, so the unit of this form of energy is joule. This is the SI system. We can also correlate to its CGS unit, or where we say 1 joule is 10 to the power 7 ergs. Coming back to an ideal gas where the potential energy is 0 because there is no interaction between the particles, internal energy depends only on the temperature. When we say is a function of temperature only, meaning it is dependent on the temperature. So if there is no change in temperature, the internal energy of this system will also, the change in internal energy will also be 0. We've already discussed the signs. That means here, please remember, throughout thermodynamics, you add to the system, it's plus. You remove from the system, it's minus. Internal energy increases, positive. Internal energy decreases, negative. Heat increases or heat added to the system, positive. Heat removed from the system, negative. Work done on the system, positive. Work done by the system, negative. For an isolated system, now here what we are talking about is a system which is completely cut off from the surroundings. In other words, it is insulated and tightly closed. Neither can mass escape nor more mass be added to it. Neither can it lose energy to the surroundings, neither can the energy of the surrounding enter it. In other words, there is no to and fro happening between the system and the surroundings. Because of this, there is no change in the status of the system. So we say delta U is 0. That means in such a state, the change in internal energy for this arrangement is 0 for an isolated system. How can we change the internal energy of a system? Of course, by changing the heat associated. I'm using the word changing. We can either heat the system, we can also cool it. So either heat passes into or out of the system. Out of the system is when you cool the system. Work is done on or by the system. So supposing I have a vessel over which I have fitted a piston. So we can either apply pressure to compress the gas. Alternately, the gas can also exert pressure to push the piston out. When we are applying pressure on the gas through the piston, work is being done on the system. It's positive. Internal energy increases. When work is being done by the system, that means the gas is expanding. Then work is being done by the system means internal energy decreases, provided we are not considering the heat over here, because later on when you study, we shall see that heat also has a role to play. Since we said that internal energy is an extensive property depending on the mass of the substance taken, internal energy of a system can also be changed by adding substance. That means by adding matter to the system. That means you add more sample, the internal energy will get changed. Next heading we shall be doing is work. I would sincerely advise you to go through this once again, go through the text, or you can visit the site Learning Chemistry is Fun Google Sites for a write-up on this. Please let me know your feedback, or you have any doubts. You are most welcome to clear your doubts on the comment section. Thank you so much.